Welcome to The Explainer. I am absolutely thrilled you're here today. We are jumping right into a fascinating journey exploring the invisible, unstoppable forces that are constantly reshaping our entire planet. We usually think of the ground beneath our feet as solid, right? Completely permanent, unchanging. But as we're going to see, the Earth is this incredibly dynamic system. It's basically a massive canvas that's being sculpted, broken down, and smoothed out right before our very eyes, if you just know what to look for. Take a look at this magnificent peak. It's majestic, it's rugged, and honestly, it feels like it's going to stand there until the end of time. But let me ask you something. What force is powerful enough to tear this massive mountain down to a completely flat plain? Sounds totally impossible, right? No way. But it isn't. In fact, it is happening every single day. Hooked yet? Let's figure out exactly how the Earth pulls off this incredible disappearing act. Okay, let's dive into this. Here is our roadmap for the explainer today. First, Earth's invisible sculptors. Then, the stages of denudation. Next up, physical weathering in action, followed by chemical and biological weathering. After that, we'll look at gradation as the great leveler. And finally, a real-world case study, a tale of two mountains. Section 1. Earth's invisible sculptors. To really understand what's happening to that mountain we just saw, we need to take a massive macro view. The Earth's surface is basically a giant battlefield between two major types of forces. On one side, we have internal or endogenous forces. These are driven by the Earth's internal heat. So think plate tectonics, think volcanic eruptions. These are the builders. They create new relief features, literally uplifting the land through folding and faulting to build these massive mountain ranges. But on the flip side, we have external or exogenous forces. And these are the destroyers, the sculptors. Driven by solar energy and gravity, they are vigorously, constantly working to wear away that newly built surface. Section 2. The stages of denudation. Let's zoom in slightly and actually put a name to this destructive process: denudation. It's the overall process of wearing away and lowering the Earth's surface, and it is a relentless force. To give you an idea of just how powerful it is, the Aravalli mountain range in Rajasthan was once as tall as the mighty Himalayas. Seriously. But over vast, sweeping stretches of time, the forces of denudation have gradually worn those towering rocks away, turning massive mountains into hills and eventually right down into flat plains. And this brilliantly illustrates exactly how denudation works in 4 distinct, sequential phases. First up is weathering, which is the breaking down or disintegration of rocks right where they sit without any movement at all. Next is erosion, the active removal of those broken down materials by natural agents. Think rivers, wind, ice, waves. Third is transportation, where those natural agents literally carry the eroded material from one place to another. And finally, deposition. When that river or wind loses its energy, the materials just settle and are laid down in totally new locations. So it goes: breaking, removing, carrying, and settling. Section 3. Physical weathering in action. To see how weathering acts like a master sculptor's chisel, let's look at something built by humans. Have you ever wondered why engineers leave those small gaps between railway tracks or bridge joints? The answer is thermal expansion. Metals expand when they get hot, and they contract when they cool down. If engineers didn't leave those little gaps, the tracks would literally buckle in the summer heat. Well, guess what? Rocks do the exact same thing. During the day, especially in places with huge temperature swings like deserts, rocks heat up and expand. At night, they cool down and shrink. This continuous daily cycle of expanding and shrinking puts immense, unbelievable stress on the rock. Just look at how the outer layers of the rock here are literally peeling away layer by layer. It looks almost exactly like a giant onion. This incredible result of thermal expansion is called exfoliation. The alternate heating and cooling on the rock surfaces strips it down. Actually, scratch that. It strips it apart. But the rock fragments left behind haven't changed chemically at all. They're exactly the same, just smaller, completely unaltered pieces of the original rock mass. Let's look at another super relatable scenario. What happens if you take a glass bottle, fill it to the absolute brim with water, cap it tightly, and leave it in your freezer overnight? Just like that glass bottle cracking and shattering in your freezer, the freeze-thaw cycle destroys rocks from the inside out. Water seeps into these tiny, microscopic cracks in the rocks. When the temperature drops below freezing, that water turns to ice. And here's the kicker. When water freezes, it expands by about 9% in volume. This creates a powerful, unstoppable wedging effect that forces the crack wider.
When it warms up, the ice melts, the water sinks even deeper into the newly widened crack and just waits to freeze again. This repeated freeze-thaw cycle is super common in mountainous and high-latitude areas, and it can eventually shatter giant boulders into tiny pieces.
Section 4. Chemical and biological weathering.
So, physical weathering breaks rocks down mechanically, but chemical weathering, it alters the molecular structure from the inside out. Now, what's really interesting about this is how chemical weathering mirrors everyday reactions we see right in our own homes. When you cut an apple and it turns brown, that's oxidation. The exact same thing happens to rocks containing iron. They react with oxygen and become reddish-brown, effectively rusting, just like an old iron gate left out in the rain. Or think about how highly acidic drinks can slowly damage your tooth enamel over time. In nature, carbonic acid in rainwater acts the exact same way, slowly dissolving certain types of rocks. These processes are absolutely powerful, especially in hot and humid regions. Check out the deep, almost alien-looking grooves carved into these massive rocks. Over thousands of years, that carbonic acid we just talked about can completely dissolve limestone, literally carving out entire subterranean cave systems. All of that from a slow, relentless chemical reaction. It's mind-blowing. And we definitely can't forget biological weathering, which is driven by plants and animals. Trees can push their roots super deep into tiny rock joints in search of moisture, and as the tree grows, those roots act like natural crowbars, gradually prizing the rock apart. Animals, like burrowing rabbits, can expand cracks too. In fact, even you are a weathering agent. Just repeatedly walking over the same patch of rock in your heavy boots will eventually wear that rock down. Life itself is a relentless geological force.
Section 5. Gradation, the Great Leveler.
So what does this all mean when we zoom back out to the macro level? We've seen all these highly localized processes: freezing, rusting, roots pushing. The ultimate long-term result is gradation. Gradation refers to the leveling out of the Earth's surface over incredibly long periods of time. And it achieves this through a very delicate balance of two opposite actions. First is degradation, the wearing down of elevated, high areas like mountains and hills through erosion. Second is aggradation, the building up or raising of low-lying areas like valleys or coastal regions by filling them with the exact sediments that were just transported away from those mountains.
So, the crucial point here is understanding the difference between these two main concepts. Denudation is the action. It's the active process doing the heavy lifting, the weathering, the eroding, the carrying. Gradation, on the other hand, is the final outcome. It's the resulting masterpiece. As the highlands are lowered like denudation and the lowlands are filled by aggradation, the differences in elevation are drastically reduced, giving us a perfectly leveled out, even Earth surface.
Section 6. A Tale of Two Mountains. To really cement everything we've covered today, let's apply these concepts to a massive real-world case study. Let's compare two of the most famous mountain ranges on the entire planet. On one side, we have the Himalayas in Asia. They are soaring, exceptionally high, and incredibly rugged. On the other side, we have the Appalachian Mountains in North America, which are much lower to the ground and feature very smoothly rounded peaks. So why the drastic difference? Well, it's purely a matter of time. The Appalachians are much, much older. They have been exposed to the relentless chiseling of denudation, the freeze-thaw cycles, the chemical decay, the erosion by rivers and winds for far longer. Their height has been drastically reduced over time. It's just incredible to think about.
Slowly but surely, through weathering, erosion, transportation, and deposition, the Earth is always working to level itself out. Nothing is permanent. Which leaves us with an absolutely fascinating question. If the forces of denudation never stop, what will the mighty Himalayas look like a few million years from now? Thank you so much for joining me today. Keep looking at the rocks around you, and I'll catch you in the next explainer.